Well, we are back to our loaf of bread. And again, if I could figure out the volume of one slice, if I then knew how many slices were in that loaf, I could multiply and get the volume of the entire loaf. And so that's what we're going to be doing with calculus, right? The slicing method. We took an introductory look at it last lesson, and we'll take another look at it here, work through another example. Now, as a reminder, to find volumes by this method, we kind of have to figure out what shape a cross section would look like. And again, at first you got to pretend that these cross sections are super thin, right, where their thickness is almost zero. So we're really just looking at the area of one side of these slices. And then we can add up all those slices, and of course we end up getting a volume. Now, of course, if a picture is not provided, I'd highly recommend drawing one. Right? I predict that most of the time, if not all the time, I'll provide a picture. Sometimes I create it myself, and sometimes I just steal a picture off the internet. Then we got to determine a formula for the area of the cross section. And then we want to integrate the, oh great, here comes one of the slices of bread. Get out of the way, bread. All right, and then finally we want to integrate the area formula over the appropriate interval to get the volume. And of course, the reason why area magically becomes volume is that the dx, or the delta x, that is the thickness of each slice. So if you ever take the area of a base and multiply by the height, you get the volume of the solid. Okay, so did two examples in the previous PowerPoint. Let's do one more example here, and then I'll give you a chance to try it on your own. So this time we want to find the volume of a cone with a radius of 3 inches and a height of 15 inches, right? All of our friends from geometry are coming back to visit us. And of course, either you would have to draw a picture or you'd hope that I provided a picture. And of course, it is lying on its side because as I make all the slices, when I add them up, I want them kind of lined up on the x-axis. So when I integrate, I'm integrating dx. And so all the little slices have to be dx or delta x. And so that's why I've got the cone laying on its side, right, instead of the way we'd normally visualize it. 15 inches, of course, is the height of the cone. And then the radius of the base is 3 inches. So what shape are the slices? And again, you see that there's a slice highlighted in that picture. And you're like, hey, instead of a rectangle like our first example, or a square like our second example, this looks like a circle. So what is the area of any given slice? Well, I know the area of a circle is pi r squared, but what on earth is the radius of any given slice? Obviously, when we get all the way down to the base, the radius is 3. Obviously, at the very apex of the cone, the top vertex, the radius would be 0, right? I mean, it's so tiny, it's not even a circle. But what would any intermediate slice have for a radius? Well, I know I'm x units away from the origin. And so I can set a proportion and say, hey, that radius r will compare to the distance x the same way that the radius 3 compares to the distance 15. All right, this was first year geometry when you were doing similar triangles, and we'd set up ratios and proportions and solve. So let's multiply each side by x. Oh, I goofed up again. just like last video, it was like, no, I reduced the fraction first, right? 3 over 15 is 1/5. Now I can multiply both sides by x. So the radius of any given slice is 1/5 times the value of x. And of course, the area of a circle is pi r squared. So the area for any given slice will be pi times the quantity 1/5 x squared. And of course, that area magically becomes volume when we consider the thickness dx. Of course, I simplified there, right? 1 times 1 is 1, so I've just got 1 times pi. 5 times 5 is 25, x times x squared. And of course, it magically becomes volume when I take the area of one of those faces, multiply it by the thickness, it becomes volume. So the thickness is dx. And now I need to add all of these up. And how do we add up a series of things? Well, we use integration. So the volume of the cone will be the integral starting at 0 and going to 15. Pi over 25x squared. That's the expression for the area of one of those cross sections when we do the slicing. Dx, of course, is the thickness of each slice. We want dx to be as small as possible, approaching 0. Well, when we integrate x squared, it becomes x to the third over 3. Now, of course, there was already a denominator of 25, so 25 times 3 is where that 75 came from. So let's plug in the 15. Let's plug in the 0. 0 to the third power, I can completely forget about that term. 15 times 15 times 15, I might want to consult a calculator. I get 3,375. So I've got 3,375 pi over 75. Again, that 0 to the third power just makes everything a 0 back there. And now with a calculator, what on earth do we get? Hey, 45 pi. And did I say cubic units again? Did I just get goofed up? No, look, I actually got it right this time. I put cubic inches because we were using inches. All right, so for any given three-dimensional object, we want to be able to cut slices, and we want, every time we want the slice to like always be a square or always be a rectangle or always be a circle, right? We always want it to be some sort of recognizable shape where we can find the area of the shape. And then the dx gets its thickness, which turns it into volume. And then with integration, we can find the sum of all of those slices. So finally, you can refer to the example on this PowerPoint. You can also refer to the 2 examples on the previous PowerPoint. And you've got a worksheet which is going to, surprise, surprise, have exactly 1 question on it. So this video is going to wrap up in less than 10 minutes. And so even if you spend, I don't know, half an hour on the worksheet, that should still tell me that you can complete this entire lesson in less than an hour, which is kind of our target at the moment. So have a good one.